Welcome to my channels. This is S.D.V Academy. I am Asra Nasni. Okay, today we will learn topics are differential equation of second and higher order with constant coefficient, complete solution, and auxiliary equation, complementary function, particular integrals in case of e power ax, sin ax, cos ax, e power ax into v, x power k, x into v with examples problems. Okay, today we will learn these kind of topics. Now let us start. Differential equation of second and higher order means d square y by dx square, this is second order, d cube y by dx cube, this is third order, and so on. Okay, d power n by d power n into y by dx power n, so this is nth order. Okay, p1 d power n minus 1 into y by dx power n minus 1, this is n minus 1 order. p2 dn power minus 2 into y by dx power n minus 2, and so on. Pn into y is equals to x, where p1 p2 p3 and so on pn are the functions of x, and x is a function of x only. Okay, capital X is the function of x only, is called linear differential equation of nth order. A linear function with constant coefficient is of the form d power n into y by dx power n and plus a1 dn power n minus 1 into dx power n minus 1. Okay, where here a1 a2 a3 and so on an are the all constants, and capital X is the function of x only. Okay, now the operator d. Let d be the symbol which denotes differentiation with respect to x of the function which immediately follow it. That is, capital D is equals to d by dx. D into y is equals to dy by dx. D into y. D of d into y. You can say like this also, d by dx of dy by dx is equals to d square y by dx square. Okay, that is d square y is equals to d square y by dx square. Okay, this is nth differentiation, and so on. When you continue it, d power n into y is equals to, this is nth order. Okay, n times differentiation. In the symbolic form, the equation 1 can be written as d power n plus a1 d power n minus 1 and so on. This can be written like this. Okay, now this value can be written as f of d into y is equals to x. Okay, f of d is considered as a polynomial. This f of d is considered as this polynomial is equals to x. Complete solution. Okay, to find the complete solution of the differential equation of nth order with constant coefficient, this can be value, and this value is equals to x. Okay, f of d into y is equals to x. So this is the where the f of d value is this. Okay, into y is equals to x. Okay, to find the complete solution, we have a theorem so that you can understand it clearly. If y is equals to f of x, this is a general solution of f of d into y is equals to 0. This is the equation, and it is equated it to 0, and y is equals to phi of x is the solution of equation 1. Okay, this is the, for this the solution is y is equals to phi of x. Y is equals to f of x plus phi of x is the complete solution of the differential equation. So this is the general solution, and this is the solution. Since y is equals to f of x is the general solution of the equation, f of d into y is equals to 0, f of d into f of x is equals to 0. So this is equation 1. This is a complementary function. Y is equals to phi of x is the particular solution. Here what it is called particular solution of the equation f of d into y is equals to x. F of d into phi of x is equals to x. This is the particular solution. Adding these two gives the value f of d into f of x plus phi of x is equals to capital X. Okay, y is equals to f of x plus phi of x satisfy the equation. Okay, now we have the part of y is equals to f of x is called complementary function. This part f of x part is called complementary function. which contains arbitrary constant. This value contains arbitrary constant. The part of y is equals to phi of x. This is called particular integral, which does not contain, this does not contains arbitrary constant. So the complete solution of the equation f of t into y is equals to x is y is equals to complementary function plus particular integral. Okay, um, this can be written in the short form cf plus pi. Now comes to the concept of auxiliary equation. Consider the differential equation. This is the differential equation which has been formed. Okay, assume y is equals to e power m of x is a solution of equation 1. Okay, y is equals to e power m of x. dy is equals to m into, differentiate it 1 times, m into e power mx. Okay, now differentiate it 2 times, d square y is equals to m square e power mx, and d cube y is equals to m cube e power mx. Okay, when you differentiate it n times, d power n into y is equals to m power n e power mx. Substituting these values in equation 1, we get m power n plus a1 am power n minus 1 plus a2 m power n minus 2 plus and so on plus an e power mx. Okay, now where these all this value is equal to 0 and this value which is not equals to 0. Okay, equation 2 is called auxiliary equation of the differential equation. Okay, this equation is called auxiliary equation of differential equation. Now comes to the concept of complementary function. Let m1 m2 m3 and so on mn are the roots of auxiliary equation. Okay, if m1 m2 m3 and so on mn are real and distinct, these are real and distinct different values, then we get the complementary function can be written as c1 e power m1x plus c2 e power m2x plus and so on cn e power mnx. If mn m1 is equals to m2 are equal, two roots are equal and real. Okay, if these roots are equal and real, then complementary function can be written as c1 plus c2x e power m1x. Okay, plus if you have m3, then we can write c3 e power m2x. Okay, you can write like this. Now if three roots are equal, if three roots are equal and real, if these roots are equal and real, then c1 plus c2x plus c3x square into e power m1x. This can be written like this. If you have c4 m4, then you can write as c4 into e power m2x. Okay, you can write like this. Now if these roots are in the complex form, if the roots are in complex, if the roots are in complex form, then e power alpha x a into cos beta x plus b into sin beta x. Complementary function can be written in this form. Okay, I'll tell you one example problem so that you can understand it clearly. This is the given example problem. D cube y by dx cube minus 6 d square y by dx square plus 11 dy by dx minus 6y is equals to 0. Now you have the auxiliary equation as m cube minus 6m square plus 11m minus 6 is equals to 0. This can be written as m minus 1 m square minus 5m minus 6 is equals to 0. You know the calculation, it's okay. If you don't know, I'll give you this calculation. Okay, this can be written as m cube minus 6m square plus 11m minus 6. So calculate it to m minus 1. This can be written as m minus 1 into m square, m cube minus m square. So this can be cancelled out and this can be written as minus 5m square. Okay, this can be written as minus 5m, gives the value, this is plus 11m minus 5 into m minus 5m square. Okay, minus 5m minus 5 plus 5m. Okay, this can be written as, cancel this out, this can be written as minus 6m. Okay, now let it comes down. Okay, now 6m, now when you calculate it, this is plus, okay, plus 6 6m means 6m minus 6 gives the value, this two cancelled out, this is 0. So when you multiply this value and this value, you will get this value. Okay, now here m value is 1 comma 2 comma 3. Okay, the cf value, this is cf value. The solution is y is equals to c1 e power x plus c2 e power 2x plus c3 e power 3x. This is solution. Okay, this can be called as complementary function also. Okay, now the other example is d cube y by dx cube minus 8y is equals to 0. So here what is the auxiliary equation? M cube minus 8 is equals to 0. Now in calculate in my way only, previous in this problem I have explained you in that same way. If you calculate, you will get the value of m as 2 and m is equals to minus 1 plus or minus root 3i. Okay, you will get the value like this. Okay, y is equals to e power minus x e1 cos root 3x plus e2 sin root 3x. Okay, now particular integrals definition. Inverse operator 1 by f of d. You have to know this operator. 1 by f of d into x is that function of x which when operated upon by f of d gives the value x. Okay, then f of d into 1 by f of d, x is equals to x. F of d and 1 by f of d are inverse operators. These are the inverse operators. Since f of d into y is equals to x, the particular integral pi can be written as y is equals to 1 by f of d into x. Meaning 1 by f of d into x. This is the value is that of the function x which when operated on by d gives the value x. Means d into 1 by d of x is equals to x. Okay, d into 1 by d. D stands for differentiation and 1 by d stands for integration. 1 by d here stands for integration. Means 1 by d of x is equals to integration of x dx. 1 by d can be written in this form. Okay, next. This is the formula 1 by d minus a into x is equals to e power ax when the equation is in the form of e power ax integration x into e power minus ax dx. You can write in this form. Okay, 1 by d plus a into x is equals to e power minus a into x integration of x into e power ax dx. Okay, I'll give you an example problem so that you can understand it clearly. Yeah, this is the example problem 1 by d minus 3 into x. When the equation is given in this form, then you have to put e power 3x integration of e power minus 3x into this value x value dx. Okay, common e power minus 3, and when you integrate this value, this is integration of uv dx. So u integration v dx plus integration v dx into dx. Okay, minus x e power minus 3x by 3 plus integration of e power minus 3x by 3x into dx. Okay, when e power 3x gives the value minus x e power minus 3x, when you integrate this value minus of e power minus 3x by 9 minus x by 3 minus 9. So this is the required answer which has been formed. For this, the formula is integration of u integration v dx minus integration of u integration of v dx whole dx. Okay, for this the integrating formula is this. Okay, so that you can understand it clearly. The next problem is find the particular integral of d square minus 4d plus 3 into y is equals to e power 2x. 1 by d square minus 4d plus 3 into e power 2x. Now when you do it partial fraction, when you divide into partial fraction, you have to divide this in the form of partial fraction. When 1 by 2 common, 1 by d minus 3 minus 1 by d minus 1 e power 2x. Okay, 1 by 2 common. When you apply this 2, you have to apply e power 2x to this value and apply the formula e power 3x into integration of e power minus 3x e power 2x is this value, and e power 3x applying the formula here, e power x e power minus x and e power 2x this value. Now e power 3x, when you minus 3x plus 2x gives the value minus x dx, minus e power x, e power minus x 2x gives the value e power x dx. 1 by 2 integrate into e power 3x minus e power minus 3x, integrating this value. E power x integrating this value gives the value this, half into minus 2 e power 2x, because minus of e power 3x minus x gives the value e power 2x, so minus half. Okay, I'm right here. So half into e power 2x minus e power 2x. Okay, e power 2x minus e power 2x. Here you have minus, so minus e power 2x minus e power 2x gives the value 2 e power 2x minus, and this half, remaining half comes down. Okay, minus minus gets cancelled out, this value gives the value minus e power 2x. Okay, now the next formula is, when you have the differential equation of the form 1 by f of t e power ax, then 1 by f of a e power ax. Here f of a should not be equals to 0. If this value equals to 0, then you have to differentiate it one time. If this value also equals to 0, then you have to differentiate it twice times, and you have to multiply x here. You have to multiply here x. Okay, e power ax. Okay, now in this problem I'll explain you, so by using that. Solve d square y by dx square minus 4 dy by dx plus 3y is equals to 4 e power 3x. Given y of 0 is equals to minus 1, y dash of 0 is equals to 3. Auxiliary equation, m square minus 4m plus 3 is equals to 0. M minus 1, m minus 3 is equals to 0. So these are the roots. M is equals to 1 comma 3. CF value is c1 e power x plus c2 e power 3x. Particular integral is 1 by d square minus 4d plus 3, 4 into e power 3x. Now when 4 comes this side, you have to differentiate this value and put multiply with the x, and the formula I have given you. Now x by differentiate one time, 2d minus 4. Okay, why? Because this is f of a, here value is d square minus 4d plus 3. When you put it 3 here, sorry, when you put it 1, 4 plus 3, this value is becoming 0, so you have to differentiate it one time. So f of f dash of a and multiply x in the numerator, so 4x into 2d minus 4 e power 3x, so differentiate with respect to d. Now 4 into e power, multiply in the place of d, put the value of 3, 2 into 3 minus 4. Okay, 2x e power 3x. The complete solution is cf plus pi, c1 e power x plus c2 e power 3x plus 2x e power 3x. Okay, now this is the value of this. Here you have to multiply. I said 1 for you to solve, but you have to put 3. 9 minus 4 into 3, 12 plus 3. What you get the value? 12 minus 12 gives the value 0 here. Okay, e power 3x means when you put f of a value, this value is becoming 0. So for you to solve it clearly, I have put the value of 3. 12 minus 12 gives the value 0. That's why you have to differentiate it one times and solve the equation. Now another problem. 1 by f of d square sine ax is equals to 1 by f of minus a square sine ax. F of minus a square is equals to 0. It should not equal to 0. This should not be equal to 0. And 1 by d square cos ax. 1 by f of minus a square cos ax. If f of minus a square is not equal to 0. Particular case, 1 by d square, if this value is equals to 0. F of minus a square, this value is equals to 0. F of minus a square, this value equals to 0. Then only you have to apply this equation. Okay, then only you have to apply this equation. You have to differentiate it one time. You have to multiply with x and differentiate it one time. Okay, here also you have to multiply with x and you have to differentiate it one times. If this case face and it is equals to 0, only you have to do this. In the previous problem also I have explained you. In the previous problem also I have explained you, if these values are becoming 0, then only you have to multiply with x and you have to differentiate. When you put 3 here, this value is becoming 0. That's why this value is becoming 0. That's why I have multiplied with x and differentiated one time. Okay, this is the example problem. D square minus 5d plus 6 into y is equals to sine 3x. Okay, here m square minus 5m plus 6 equals to 0. M minus 3, m minus 2. The roots of m are 2 and 3. CF value is c1 e power 2x, c2 value is c2 e power 3x. Pi 1 by d square minus 5d plus 6 sine 3x gives the value, put the value 9 here, 3 square means minus 3 square gives the value minus 9. Okay, minus 9 minus 5d plus 6 sine 3x. Okay, minus of 1 by 5d, taking common, minus 1 by 5d minus 9 plus 6 gives the value minus 3. I'm taking minus common, so plus 3 sine 3x. Now multiply and divided by 5d minus 3, 5d minus 3 gives the value a plus b into a minus b. This formula is becomes like this, means a square minus b square. So here 25d square minus 9. Okay, in the place of d square puts the value minus 9. Okay, gives the value 25 minus 9 minus 9. 1 by 234 and 5d minus 3 means 5 into differentiate this and minus 3 into sine 3x. Now 1 by 234, 5 into 3 cos 3x minus 3 sine 3x. Okay, when you differentiate it, it gives the value like this. Now 1 take 3 common, gives the value 1 by 78, 5 cos 3x minus sine 3x. This is the required answer. Now complete solution is c1 e power 2x plus c2 e power 3x. 1 by 78, 5 cos 3x minus sine 3x. Okay, this is the required solution which has been formed here. Now the next formula is particular integral. When the value of x is in the form of x power k, when the value is in the form of x power with where k is a positive integer here and 1 by f of d into x power k, you have to reduce 1 by 2 f of d to the form of 1 by 5 of d by taking out lowest degree term from f of d. Okay, now write 1 by f of d as 1 by 5 of d and you have to expand in the form of binomial form. Okay, these are the two formulas, 1 plus x whole inverse, 1 minus x plus x square minus x cube and so on. 1 minus x whole inverse gives the value 1 plus x square and plus x cube and so on. You have to reduce this value and you have to expand in the binomial form. Okay, while seeing the example problem you can understand this concept clearly. Now this is the example problem which has been formed. D square plus d plus 1 into y is equals to x cube. Okay, now auxiliary equation form is m square plus m plus 1 is equals to 0 and m value is minus 1 by 2 plus root 3 by 2 I, minus 1 by 2 minus root 3 by 2 I. So what it will be the CF value e power minus x by 2 c1 cos root 3 by 2 plus c2 sin root 3 by 2 into x. Okay, root 3 by 2 into x. So this value here you have x. Now pi value is 1 by d square plus d plus 1 into x cube. Now take 1 place d square plus d whole inverse. When this value goes upside gives the value minus 1 into x cube. So this is the binomial form expansion, binomial form expansion, and where the value of this is in the form of x. Okay, 1 minus d square plus d square plus d whole square minus d square plus d whole cube plus and so on. Okay, expand up to d cube times d degrees. Okay, 1 minus d plus d cube. Okay, plus d cube, that equals to differentiate 1 times x cube minus 3x square plus 6. When you differentiate it remaining times this value becomes 0. 4 times means this value becomes 0 here. So 1 minus d, here minus d is there, plus d cube. Okay, this and this value gets cancelled out. So this is the particular integration solution. Now what is the complete solution here? Complete solution is complementary function plus a particular integration. So this is the complementary function which has been formed. This is the particular integration solutions. So this is the required answer which has been formed. Formula: particular integration for x is equals to e power ax into v, where v is the function of x. Okay, where v is the functions of x only. Then you have to do 1 by f of d into e power ax. When you put e power ax above, then 1 by f of d plus a. You have to add the value into v. Okay, this is the example from problem which has been formed. D cube minus 7d square plus 14d minus 8 into y is equals to e power x cos 2x. This auxiliary equation m cube minus 7m square plus 14m minus 8 is equals to 0. So m minus 1, m minus 2, m minus 4 are the required roots which has been formed. So what is the CF value? C1 e power x plus C2 e power 2x plus C3 e power 4x. Okay. Now what is the PI value which has been formed here? Now for calculating PI value, 1 by f of d you have to write. So 1 by d cube minus 7d square plus 14d minus 8 e power x cos 2x. When you take this to previous e power x, so you have to add the value d plus 1 whole cube minus 7d plus 1 whole square plus 14d plus 1 minus 8 into cos 2x. Okay, now when you calculate this whole value, gives the value d cube minus 4d square plus 3d cos 2x. Okay, in the place of d cube gives the value minus 2 square, and in the place of d square you have to write minus 2 square. Okay, in the place of d cube, in the place of d square you have to write this value. In the place of d cube you have to write d into d square. So d into minus 2 square, that is equals to d into minus 4. Okay, you have to write like this. So d into minus 4, minus 4 into minus 4 plus 3d. So what it gives the value? 1 by 16. When you calculate this, gives the value 16 minus d. 1 by 16 minus d into 16 plus d by 16 plus d gives the value in the form of a plus b into a minus b, gives the value x a square minus b square. So what's this value given? 16 square gives the value 256 minus d square cos 2x. 16 plus d 256 minus of minus 4 gives the value cos into cos 2x. Okay, e power x into 16 plus d by 260. When you add the values, 256 plus 4 gives the value 260 cos 2x. E power x 260 into 16 into cos 2x plus d into cos 2x. We have to differentiate it one time, gives the value minus 2 sin 2x. So when you take the common, 2 gives the value 138 cos 2x minus sin 2x. Okay, this is the complete solution. Y is equals to c1 e power x plus c2 e power 2x plus c3 e power 4x. This is complementary function, and this is the particular integration which has been formed. Now comes to next concept, formula. Particular integrals for x is equals to x into v, where v is the functions of x. Okay, 1 by d x into v. Now you can write this function, this problem in this form also, in this form, and in this form also. Okay, now x into 1 by f of d into v minus f dash of d by f of d whole square. Okay, taking f of d into v common gives the value x minus f dash of d by f of d. Now this is the example problem. We can solve d square plus 2d plus 1 into y is equals to x sin x cos x, x cos x, m square plus 2m plus 1. Auxiliary equation is, these are the roots. M is equals to minus 1 minus 1. So CF value is y is equals to c1 plus c2x e power minus x, which has been formed. So for finding the particular integral value, 1 by d square plus 2d plus 1 x cos x, 1 by f of d into, I am substituting the formula, x minus f dash of d by f of d into x cos x. So what is the value? F of d is equals to d square plus 2d plus 1. Now f dash of d here gives the value 2d plus 2. Okay, now x into 2d plus 2 into d square plus 2d plus 1, 1 by 2d square plus 2d plus 1 into x cos x, x minus 2d plus 2d square plus 2d plus 1 into 1 by minus 1 whole square. In the place of d square you have to put minus 1 square, minus 1 square 2d plus 1, and these two values get cancelled out, x cos x. Now what you get the value here? X minus 2 by d plus 1, 1 by 2d cos x. Okay, and integrate this value, gives the value cos x dx. So this gives the value sin x. Okay, now separately multiply x by 2 into sin x. 2, this 2 gets cancelled out. 1 by d plus 1 into sin x. Okay, x by 2 sin x, 1 by d plus 1 in the form of a plus b into a minus 1. To form this value, what we have to do, d d minus 1 d minus 1 add multiply with the numerator and denominator gives the value this. So what this value gives my d minus 1 d square minus 1 sin x. So what this value gives, d square minus 1 whole square minus 1 sin x minus 1 by 2. This minus when you put it value put here gives the value, this is value becomes add 1 by 2. Now multiply d sin x minus sin x x by 2 sin x plus 1 by 2 cos x minus sin x. So these are the values which has been formed. So complete solution is y is equals to c1 plus c2x e power minus x plus x by 2 sin x plus 1 by 2 cos x minus sin x. Okay, hence this completes the topic here. Now thank you and have a nice day. Please like, share and subscribe. If you have any concept doubts, please comment me in the comment section.